Take a look. This is a follow-up of a class we did last Sunday. And you can see this is a roof that has varying plate heights. This wall here is higher than this wall here. So the common rafters go up, and when they reach the ridge, they come down the other side and land on a higher wall, so the ridge isn't centered. That means all these common rafters are shorter, and these hips land on the same wall, and then everything else spills down to a consistent plate height here. What I want to talk about now is this method of framing by which all of it is 2x material, so whatever, 2x8, 2x10, whatever. But the common rafters, the hip rafters, and the ridge are all 2x, and you have what's called an end of ridge king common that runs down in plane with it. And then you have king commons on either side. There's a short king common and a longer king common, right? And the way that frames at the top is like this. You'll have a ridge running along, they'll stop, and these three common rafters, end of ridge common rafter, end of ridge king common, and these two king common rafters, you can see the corners all meet here. So they're all the same length. That means that the ridge extends an additional 3/4 beyond the framing point, and that's the framing point where all of the framing members converge at one single point, so that when you cut plywood, everything's pointed up there. Right? So the mathematical length of the ridge is to here, but you have to add half the thickness of the common rafter to come out to here, and then you'll see like all three of these are the same, and then the hips die into the cruxes that are created here. Right? So here's that situation there. Over here is the same thing. You have end of ridge, and in fact it's the same length. If you pan out, you can see these go from a consistent elevation and land at a consistent lower elevation around the building. So this one has an end of ridge king common. This side's a king common, and this is a king cripple right here. And the purpose of to frame a king cripple like this is a transition between jacks. So if the center spacing were closer together, you'd have some jack rafters up here, and there'd be different types of jack rafters. You see this one is what's traditionally called the hip to valley jack, because it goes from the hip to the valley. We would just call it a double step jack because of the method by which you achieve its length, or their length if there's many of them. This is a transition between this side and that side. So if you can get this length here, it's easy to find these lengths here and these lengths in here. Here's another ridge, a shorter ridge, and it has a king cripple and an end of ridge king cripple here, and then king common here. So end of ridge and then king common. Here, just like over there, two king commons and then one end of ridge king common. So what I'm going to talk about now is how to get the lengths of these, and by doing so, make calculating all these jack rafters a lot easier. Starting with this one here, you see this is a gigantic rectangle, right? So is this one here. It's a gigantic rectangle. So I'm going to use this one instead. And I'm going to divide it in half because all ridges are centered unless it's varying plate heights or the pitches change. So these are consistent plate heights, and the pitches on either side are the same, and we know that because it's called that way. So what you do is then divide the span in half and mark from the center line 3/4 on either side. And then you pull from the corner, equidistance on this side, and that'll locate where the ridge begins here, right? So that will give you the location, position of these king commons and the end of ridge king common. So when the time comes and we lift this ridge up between these two commons that are nailed at the bottom and nail it off with maybe one here and a temporary running down to here or a post, making it level, we throw this end of ridge king common in there and nail it off, and it'll stabilize the ridge and lock it in from going back and forth. It's really important. So that's how to get these. So the span is from outside of plate to outside of plate. Subtract the ridge thickness, divide it in half. That gives you the run, and you multiply it by the secant of the rafter, which is the multiplier. You write it down and then multiply it by the runs. There's a secant for the hip and a secant for the common rafter. Another name for them are line length ratios. Hip valley line length ratio and common rafter line length ratio. Over here, so let's get this ridge length. Since we're over here, let's get this ridge length. Take a look at this. It's a parallelogram. These two lines are parallel. These two lines are parallel. And these angles are equal to each other. Right? So it's clear to see that this length from center line of valley to center line of hip is the same as the ridge, the theoretical ridge length here, right? The only difference is you have to add that 3/4 that we were talking about right here. Half the thickness of the common rafter, king common, on one side, which is this side, and then the other side, you have a valley that runs up, turns the corner and becomes a broken hip and dies into this higher ridge here. And the way this frames out is right here. And essentially, the valley comes up, dies into the face of the ridge, goes in halfway, comes out halfway. Two halves make a whole, right? And continues on up, broken hip. So that means that the ridge thickness and the gap between the hip and valley, broken hip and valley, are the same. 1.5 inches, 1.5 inches, right? Stands to reason. 3/4, 3/4, right? Up. So what we have to do, since this is the framing point, that's the mathematical length here. That is to say, the length from that was given from plate to plate. I mean, from center line to center line. Is here. We have to add an additional 3/4 to go from the middle to where we begin the hip rafter, and then we have to give it a seat there for its side cut. So we have to add this amount here, right? So far it's 3/4, and then this amount is 1 inch. And the way we know is we just simply throw a square up on top of a 2x4 or something, and then measure it, and it's 2 1/8. Half, that's 1 1/16 inches. So from the center line, we need 3/4 plus 1 inch, or 1 3/4 inches, and then just a little bit left over, right? And that'll give us enough. So 1 3/4 inches on this side, right? 3/4 on the other side. It's this length, which is also, by the way, called out, 48 plus 3/4 plus 1 3/4 inches, right? So that is 50.5, right? 50.5 inches. So that's this ridge length here. We can do the same thing over here to find this ridge length. It's a little bit more difficult though, because there's varying plates. We come up, we step up. This is a 9/12 pitch called down on the plan, say. We step up, and this is a 27-inch rise. These two plates are 27 inches different. And we have to figure out where these common rafters would spill down and terminate. And so we have to divide the rise, the actual rise, by the unit rise. This is a 9/12, and the unit rise is 9, and come to find out 27 inches. There's 3 9s in 27, or 3 times 9 is 27. So that means there's 3 unit runs of 12 inches, which is 36 inches. So that makes it pretty easy. To 84 inches, we add 36 inches. This is 7 feet, 36 is 3 feet. So this is a 10-foot span. So from this corner, we pull 5 feet to the center line, measure 3/4 on either side. Same corner, do the same thing here, right? And then you can see if if this plate is in line, we can also do the same thing from over here. So we just, from over here, we can pull the 5 feet to the center line. Granted, this is up on a higher plate, so we'll have to plumb up onto the plate, but more than likely the plate will stop somewhere in the vicinity. But anyway, plumb up to the plate, 5 feet and then 3/4 on either side, 5 feet and 3/4 on either side, and then measure from the outside of this one to the outside of this one, and that'll give us our ridge here. So that's nice. We got those 2 ridges here. And what about this ridge? Granted, this is laid out perfectly at 12 inches on center. And it looks like this would be 2 feet, right? But in actual point of fact, it wouldn't always play out that way. So, but what would is this broken hip, right? We would know this broken hip rolls on down to here. In which case this valley and this supporting hip could be a supporting hip. Just hold up the ridge and then all of that would be in line where they landed, right? Stands to reason, up, down. So whatever this plate length is, 48 inches, we subtract it from this one, which is 72 inches, and the remainder would be 24 inches. And we'll use the same method by which we determined the length of this ridge and say it's a parallelogram. This is 24 inches here. And this situation here is where we add, like we did here, 3/4 of an inch to the end of the ridge on this side. And then we need to seat cut like we did here on the other side. We had to add 3/4 plus an inch. Not a seat cut, but it's a long enough, the ridge has to run long enough, sorry, over here, to seat the broken hip, which is, by the way, on the opposite side, but it doesn't matter, same deal, right? Additional 3/4 and then an inch, and it gives us enough to nail the side cut. I guess it wouldn't be considered a seat, but enough ridge to nail the side cut. It's a double cheek cut, or a double side cut, whichever you prefer, to the ridge, leaving that 1.5-inch gap, or cutting the valley and the broken hip so they kiss each other, and that'd be just like a 1/4 inch of wood left over when these two ran into each other. It'd be a long seat cut with a 1/4 inch, long side cut with a 1/4 inch return there, which is the right way to do it. Don't do it that way. We frame it this way, run a block if we want. Sometimes run a block in there just to make it easier to stack. The broken hip has to plane over the top. So this lead edge belongs to this plane here. So this lead edge has to plane over the top of that ridge. So this whole broken hip frames high up on the ridge. Planes over this side here. Boom, we got that one. How do we get the actual... Oh, we're going to stick to the end king commons and king cripples. How do we get this end king cripple length? And you'll notice that this length in plan view is the same as this length from center line to center line, because this hip bisects the corner, the 90-degree corner at 45 degrees. And so this one here, the same. This is called out at 24 inches. If you were to slide this up, you can see this one too is 24 inches from center to center, but there's a deduction down low. There's not only a deduction, but there's a setback, which means we have to get to the side of the board in order to run our cheek cut, single cheek cut down here. So we have to do a deduction from the center line and then a setback to run our saw so that it runs through the center line, if you will. And that looks a lot like this one here. You know, here's the deduction from the center line to the center of the jack rafter and king cripple. And then we have to go over and over to get to that point to run our saw through, right? So we draw a line on the side of it. So we know 45 thickness of a 2x member is 2 1/8. Half of that's 1 inch or 1 1/16. And then we know this is 3/4 of an inch. So 3/4, 3/4, 45. So 1 3/4 inches to the short point on that one. And that's this situation here. And then at the top, it's this situation here. This is the end of, this is just flip, but this is the end of ridge king cripple here where it stacks in between these two, right? We have to, and we're here, we have to, and this is the center line, we have to go subtract 3/4 here. So 3/4 at the top, and then 1 3/4 to the short point side. Or if you want to use a skill saw or another kind of saw, just 1/4 inch. Subtract 1/4 inch from the long point side. And that's because you subtract 1 inch to center, but then you have to add 3/4 to the long point, right? Because you can see this is here and we have to start the saw there and run it along the side. So it's either 1/4 inch or an additional 3/4, depends on what side. So this would be 1 3/4, and this would just be 1/4 from the center line. So that's how you get that. And then these ones here are easy to get. And they're easy to get because you have two center lines that are parallel to each other like that. Comes like that. And both of them have some kind of a thickness to them. Right? Now, if you ran the side of the rafter down and just measured from inside of actual framing member to inside of actual framing member down from there to here and measured it, in plan view, that would be the length of the slider jack. Called sliders, because once you cut one, it can slide up anywhere you want between the two, assuming these are parallel, you know, framed correctly. Just multiply that run in between these two sides by the secant, also known as the line length ratio, which is 1 1/4 or 1.25 for a 9/12 pitch. You know, so 1.25 of, you know, whatever this is, 22 inches, because of 45 thickness of each one of these framing members to get to the side of it is 1 inch. So, you know what I mean, minus probably 1/8. So, you know, instead of 22, it's 21 7/8 times 1.25. Give you these lengths here. And then from the leading edge of this one here, you know, I'm going to forego that. Talk about this one. How do you get this king cripple here? This seems like the hardest one in a roof. But really, if you look at it, if you were to take this line on down right here, then you can see it's parallel. It's a parallelogram like we did over here, right? So from center line to center line, right, it'd be the same length as this ridge, or this right here, minus this jog, right? This jog. So we want to know what this jog is if we wanted to subtract it from the overall. But if we didn't know what it was, because it was a complicated, you know, parts of an inch, inches and parts of an inch kind of thing, we already know what this ridge length is. We calculated it before. So it's center line to center line. And then when we get, and then we subtract it from this length and we get this leftover. In this case, the leftover is 2 feet, right? And the way this works, it's funny because it's the same thing, right? You have to imagine this is center line to center line, and we have to subtract 3/4 up above and 1 3/4 down below. So 24 minus minus 3/4 and 1 3/4 would give you whatever it gave you. And then you multiply that by the secant or line length ratio to give us, which is 1.25, to give us the actual length, and it would fit right in there. It would fit right, be this one here, right? Fit right up against there. Minus 3/4 here, and then down here it would be minus 3/4 plus, and an additional inch, you know. So that's, well, my bad, it'd be down here. Minus an inch, minus an additional 3/4. Same thing, 1 3/4, which is a number you'll see a lot. So 3/4 up top, 1 3/4 down low, times 1.25 gives you the length of this one. These ones we already have, because this is the only one we don't have. But we know that if this is 5 feet, and we said that went out an additional 3 feet, when we subtract it, the leftover would be 2 feet. So these would be 2 feet minus, you know, or this amount from this side of the ridge, which is also the common, this side of the ridge, common, to the wall would be 2 feet minus half the thickness of the ridge, 3/4, right? So that would be what, 23 1/4 inches? I do everything in inches, boom, times 1.25 would give you the lengths of these, which is the one we're looking for. So we have these two. What else do we have? We have this one because it's the same as that one. We have this one because it's the same as that one. We have this one. We got this one, and we have these ones, right? So with them, we can add an additional. From this one, you can add 1 step, 2 steps, and 3 steps to the actual length of this to get the lengths of these. And a 9/12 is 1.25 times 12, and this is 12 inches on center. That's why it's times 12. So 1.25 is the line length ratio. You multiply the run by the line length ratio to get its length, the rafter length, up the rake, right? The common difference is the on-center spacing times the line length ratio, because whatever happens one way happens the other way, right? So, for example, the common difference is the length of same side to same side, which is 12 inches, times 1.25, which is 15 inches. So whatever this length is, you add 15 and then 30 and 45 to get these three, right? This length plus 15 is this one, this length plus 30 is this one, this length plus 45 is this one here, because this one dies on the side here. Because they all meet in the same point, but this has some thickness to it, there's going to be a side cut or cheek cut, single cheek cut there. And then we talked about before how to get the lengths of all these jacks from the end, from the King Common. And it has to do with this on-center spacing. Same thing, right? Whatever this is, you start subtracting your 15 inches from it and measuring up, and that'll give you the first length. Measuring, so first one, we start and measure down the spine of this. Well, first, and mark the back of it, say. And then measure from the bottom to the last mark, and that'll give you this length. From the bottom to the second to the last mark, that'll give you this length. But first we have to figure out whether it's a short point or long point, and see if we have to do a deduction first. And the answer is yes. Now, if you imagine this was in reverse, here's how it frames, right? We want to get to the side of the hip rafter, because all our cheek cuts are going to look like that, and they have to land against the side of it, right? That's an arrow showing you that this whole thing can slide over and land against it, right? So in order to do that, we have to do a deduction of half the 45 thickness, which we said was 2 1/8, and that would be 1 inch. So first we'll subtract 1 inch, and from there, whatever our on-center spacing is in the actual rake, down the rake of it, on the spine of the common rafter that we have already cut, from that point, which is overall length minus 1 inch. We measure down the spine 12 inches times the secant, or line length ratio, which is 15 inches. So minus 1 inch, then mark 15 inch, 30 inch, 45 inch, right? You got it. 60 inch. And then from the bottom, we measure up, and each one of these to be to the short point, right? From the bottom, we measure up to it, and we cut a rafter that's that long to the short point, and that'll be this one, so forth. But we actually cut two, because we have a right hand and a left hand. That'll give us all those jacks. And then some of them will be redundancies. Like this one, we'll have to cut 2 of these because they fit right here. Or looks like we have to cut 2 of these 2. Right? This is exactly 2 feet because we removed exactly 3 feet. So there'll be a rafter right there. Right? Probably because the center line is the wall itself, it'll be a little longer. So I take it back. In this case, the side is the wall. Or that is the side in our case, because there's a giant model behind me that I'm gonna shoot another video on about the same thing. I'll show you there's a wall here, and this is a ledger, not a different wall height. It's just a ledger on the wall itself. These rafters go up and they land on this ledger that's on the wall. So the side of the rafter instead of the center of the rafter is gonna hit the wall. So that means the rafter would be too short. So we'd have to do an individual calc for that, adding the 3/4 of an inch, but nevertheless, 1, 2, 3, 4, and 4 right-handed. And then this one here is the same as this one here. So you cut that one. This one would be custom. And then it would be the same, oh, it wouldn't be the same. These would be the same on that side there, right? Yeah. And then same thing with this. You'd do the same thing for these jacks here. So in King Common, or in King Common, whichever you prefer, minus 1 inch, and then start stepping down and measuring from the bottom up to the short point. Gives you the lengths of these ones all the way around. These are commons, so we know these are simply the run times 1.25 for a 912. We got these sliders already, right? We didn't get this one here, but this one here and this one here are the same length, because this ridge is 2 feet, remember, right? Center to center. And this one here we calculated out was 2 feet also. So these, once you get one of these, you just cut another one with this one I mean. This has a left-handed cheek cut at the bottom. This has a right-handed cheek cut at the bottom. That means when you're in the middle of the rafter and you're staring down at it, on the top of it, the cheek cut's on the left side. When you're standing in the middle of this long rafter and you're looking up or you're looking down, when you look down on it, from the top of the rafter, the cheek cut's on the right side. So these are the same length, but this has a right-handed cheek cut and this has a left-handed cheek cut. This has a left-handed cheek cut, right? Same with this one, look. Right? All you have to do is take this length, subtract 15 inches to get this length, right? Because that's one step. Everything else about the top of these rafters are the same. They both die into a ridge. Only the bottom changes in terms of length, and it's perfect on-center spacing. So it's one step. So 12 inches, because it's 12 on center, same side to same side, 12 inches on center, times 1.25. You know a quarter, 2.5 is a quarter. Quarter of 12 is 3, so you add 3 to 12, and that gives you 15 inches. This one here is 15, this one is 15 inches shorter than this one, right? And so on.